dx. You know how we had special notations for derivatives? Well, here's how I'm going to let you know that I want you to take an antiderivative. So what I'm going to do is I'm going to write the function down, f of x. And in front of it, I'm going to put a symbol. The symbol I'm going to put is going to look like that. So what it is it's like an S. Sorry, it's like an S, but I've stretched it out so it looks like this thing. Okay? It's like a stretched out S. And that actually has a name to it. This is called the integral sign. All right, it's the integral sign. But for us, it's just telling us, hey, go find the antiderivative, okay? There's one other thing in the notation that we have to add. There's one more little thing. At the end of this, f of x, we put dx. And I don't want us to get too confused about that, okay? This is the thing that's important. This dx, it keeps track of what your variable is in the problem, all right? So our variable is x. That keeps track of it, and that's about as much as I want to talk about in terms of this, because I can confuse you very easily if I start getting into it too much, all right? So, with that said, what is that? That's equal to natural log x plus c, okay? What is this? We did that earlier. 1/8 x to the 8th plus c, right? So it's just new notation, that's all that is. But that thing is called the integral sign, all right?
We never add that to our, like, answers?
Nope,
Okay.
nope. This is just telling you you have to do something. So when you see that, you're like, hey, that means I need to take the antiderivative of that, okay? And I'm going to ignore that. So take the antiderivative of that function. Oh, it's just natural log of x.
One question, sir.
Yes?
Is that dx supposed to be c?
Nope.
What is it supposed to be?
I just said I don't want to get into it
Oh.
because it's just going to confuse you. I mean, it is a confusing, even in a Cal 2 class, it confuses my students until we get deeper into it, and then I can explain where it comes from. Okay, yeah, so I want you to just really kind of ignore this. Just, this is the most important thing right there, all right? And then that's telling you to find the antiderivative. We didn't talk about this one, though. What would the antiderivative of this be? Don't overthink this. No, that's the derivative. 4x. 4x plus c. 4x plus c. What would the antiderivative of negative 3 be? Negative 3x plus c. So basically, if you have a constant in here, right, and you take the antiderivative, it's just the constant times x plus c. If you have a constant, antiderivative is just the constant times x plus c. All right. That's it for today. What I'd like for you to do for your homework is work on that problem that I gave you. Okay? And then on page 706, everyone got this? 706, number 38 is another inventory control problem. That's what you should also do for homework, okay? So I'm not going to collect that, but that's what you should look at for homework. Actually, 38's a good one, but also 37 is good. 37 and 38 if you want practice on that. And then in terms of the antiderivatives, we're kind of still fresh in this. So maybe just do page 722. How about 15 through 21? 722, I just do them all. 15, 722. 15 through 21. Yeah. Now, when you get to that homework set, you might see something like this. let's say you have something like this, and I know this is going to cause a problem, so that's why I want to address it real quick. Do you remember that when we were taking derivatives, if we had a constant attached to a function, we could just bring it for the ride? Do you remember that? It works the same way when you go backwards, antiderivative. So if I wanted to find the antiderivative of this, I would ignore the 5, and the 5 would be sitting here in my answer. Okay, so the 5 is going to come for the ride, and then I just find the antiderivative of x squared. All right, which would be 1/3 x cubed, using the power rule. That would be 1/3 x cubed plus c. Do you follow me? No?
Yes.
Cover up the 5, use the power rule on that, which I erased the power rule, but you add 1 to the power, you divide by 1 over the power plus 1, so 1 over 2 plus 1 gives you 1/3, and the 5 just comes with you. Now, we would want to put that together and make it 5/3 x cubed plus c. That's what we would want. Okay? So as you do these problems for homework, anytime you have that number there, just kind of ignore it, bring it to the answer, and just work on the thing that has the power. All right, exams. You know what? I'll just call names out. Okay. Annalisa. Laura Vera. Laura Vera, no. Audrey. Diego. Lauren. Marissa. Adam Ruiz. Nicholas.